So we're going to talk about how to incorporate project-based learning into campus energy projects. And I think we touched on this a little earlier, Josh and I this morning. Like I said, I'm Kornbluth. I'm a professor in bio and ag engineering. I run the program for international energy technologies in D-Lab, and I'm very involved with the energy graduate group here at UC Davis. Melody? Oh, are we going to introduce ourselves? No, okay.
I'm Melody Baglione. I'm professor of mechanical engineering and also the chair, and I advise our campus on energy efficiency. And
Meena?
Yeah, I'm Meena. I'm a second-year master's student in the energy graduate group at UC Davis, and I'm helping to facilitate the Zero Net Energy class for this year.
Great, thanks, guys. So we're going to introduce you to a little bit what's been going on at UC Davis. I'll talk for a little while, but I'm actually going to give Meena the lion's share of the time, hopefully, that she can talk about what she's actually doing on the ground to make this effort happen. Cooper Union, Melody will talk about Cooper Union and project-based learning going there. We're going to have an interactive activity to just sort of see where people are at with some of these educational activities on campus. Wrap up. Remember, type your questions in the box. The chat is enabled, so just like before. So a little bit about UC Davis. I talked earlier about this progress, research, education, and outreach, how we're doing this sustainable campus, sustainable cities. And today I'm going to talk a little bit about the education, which is project-based learning with the energy graduate group. So we'll hit the next slide. Today, what we're hoping is that we can share stories, our stories, Melody stories, some of your stories, and really we would love to begin collaboration. So I'm going to be reaching out to you all out there, and if you want to learn more about what we're doing, or if you have a great idea for a course that you want to share with us, please, after this session, let's get together. So we want to share curriculum, and we really want to inspire project-based learning because we found it as a great way to further our agenda as far as energy and sustainability and education. So I run the D-Lab, and that's kind of where this project-based learning is founded within. And it's really development of people, of societies through dialogue, design, discovery, and dissemination. It's using kind of a project-based, design-focused model to solve problems, but interdisciplinary. So hit the next one very quickly. You know, we work with multidisciplinary teams from all over the place. This is just a snapshot from our last Zero Net Energy class. You'll see we get people not just from engineering, which you typically expect, but from all over, all different engineering and also sciences, as well as management, economics, community development, design. So really, we try to get these teams together, both undergraduate and graduate. You can hit the next slide. So while the teams are multidisciplinary, the projects are interdisciplinary, and they cross over environmental, economic, social, technical areas. And so we try to make sure that the students not only have the skill set to do this, they act as consultants for their clients, but we also want to make sure that they get that kind of experience. So when they go out, they can say, oh yeah, I've worked on a consulting project. You can take the next one. And learning by doing, very important. I love going in the shop and working and measuring and going into buildings. And we want to make sure that our students do that. So in the course, there's a combination, and Meena will talk more about this, of real hands-on learning by doing and actually touching, seeing, feeling, hearing all these different technology and as well as solutions and the problems. Client focused, I think this is really important. The students are answering to their client, not to the professor. So really, they have a scope of work. They have a client who may have a clear, may have a hazy scope of work. They have to figure out what the real problem or question that's being asked, and they have to get the job done. And then we do supply them with mentors to advise the team. So we're really trying to put them in a real consulting sort of environment. Okay, the next one. And then what I think other people, faculty may be interested is publishable results. We do try to spin these, a lot of these projects that happen in the class have been going on or will continue. And we like to often find energy students who want to focus on these and kind of dig down deeper and try to publish it. That also helps me because that way my agenda, which is publishing, getting out in the world outreach, is also met. My education agenda is met, and the students are getting a great experience. So for me, it's actually easier than harder to do this kind of thing than a traditional class. Hit the next one. And now Meena is going to talk about what she's doing in the course, The Path to Zero Net Energy, what she's doing and how it works. Go for it, Meena.
Thanks, Kurt. Yeah, so as I mentioned, I'm one of Kurt's students working on helping to organize and facilitate the course for this coming spring. And I took the Zero Net Energy course last year, and I had a great experience, so much so that I'm helping with it this year. So I'll talk a little bit more about how we do that exactly. If you could go to the next slide. Yeah. So this is a high-level overview of how the planning for the course usually goes. So about 6 months before, we start reaching out to potential clients and guest speakers. And we also start to design the curriculum material or review last year's materials if the course has been done before. And in the next few months, we discuss back and forth with potential clients to develop the project ideas and try to make sure that the projects will be a good fit for the class. And I'll talk a bit more in detail about how exactly we determine that later. And then 3 months before, sorry, not yet. 3 months before we start recruiting students for the class. And this part is really important. So we actively promote the course through flyers, social media, and other faculty and students. And then we finalize the course materials and monitor enrollment leading up to the course to make sure that we have enough students and finally teach the course. Next slide. So now I'll give a bit more detail about how we go about finding good clients and projects. So on the client side, we're looking for, of course, people who are responsible for some energy consuming facility, whether that's a campus classroom, lab building, or a wastewater treatment plant, housing community, and so on. Or they might have energy related work like a faculty member doing energy related research. And ideally, they would have clear goals or project ideas already, but this is not always the case when we first contact them. But as long as they have some idea of the change that they want to make, we can then work with them to better define these points. And it's really important that they're good communicators. It's usually good as well if it's an organization that they have a particular point person who can dedicate a couple of hours a week to working with the students once the course starts. Next slide. So for projects, we're looking for ones that seem like they can be completed, or maybe if it's part of a larger project, then have a section that can be completed within the class time. And sometimes if the client has a long list of things that they want accomplished, then we can split that into 2 or more projects so that we can still fit it within the class timeline. It's also important that we can gather as much data as possible before the course starts. So when we're doing the course, then we don't run into any data access problems during that time. And a good project ideally would also have a clear outcome that the clients want. So for example, a feasibility analysis or options for replacing equipment, and also what form they want it in, such as a written report or a presentation. And all of these things might not be apparent, like I said, when you first talk to a client about the project ideas. So it's important in that first few months of project planning to discuss with the clients until you feel like you have the projects at a good place before the class. So these are the projects that we're, some of them that we're considering for this year's class, and they demonstrate a few of the different project types that we usually have. So this first one is a vacant buildings energy auditing project, and it's a good example of how you can tie projects to ongoing research or sustainability efforts on campus, since it's part of a faculty member's research in this case. The second one is a feasibility study. The university retirement community is interested in technical and financial feasibility for solar and battery storage, in addition to assessing energy efficiency. And this is a case where the client had a lot of ideas for what they wanted to address in the facility. So we worked with them to categorize it into 2 projects so that it can still fit within the class timeline. And finally, the energy audit tutorial website involves updating the design and content to be more user-friendly for energy audit beginners for this website. And we actually use the website in the class to help teach about energy auditing. And this was a project that I worked on last year. As Kurt mentioned, sorry, not yet. As Kurt mentioned, there are interdisciplinary zero net energy problems. So we have interdisciplinary projects, and not every project has to have a focus on engineering or data analysis. We also want to incorporate more of these education or design-oriented elements. So I've said this before, but I'll emphasize it again. Recruiting students is really important. We need enough people to be able to split the class into groups of around 2 to 4 to work on the projects that we spent so much time putting together in the beginning. And to help encourage more students to take the course, you can connect it to degree requirements. So for example, in this case, my graduate program, this course fulfills a subcore requirement. And when recruiting students, you also want to think about the proportion of graduate to undergraduate students. In this case, it is a graduate course, but we also allow some upper division undergraduate students, and they've ended up being some of the best students in the class. And we're trying to recruit more broadly across students with a range of experiences. So recruiting both undergraduate and graduate students helps with that as well. And the experience and interest of the students is also important to consider when you're matching students with the projects that they'll be working on. The next slide, thanks. So now I'll just briefly go over the curriculum content that we usually include. So for the core content, we go over energy management at UC Davis, some project management and research methods. And this is all supposed to give students the skills and the tools that they need to work on their projects. The labs and activities then reinforce that with hands-on experience, both for the energy management skills like energy auditing and also the more project management related skills such as making an elevator pitch and presenting. The guest speakers component then ties the class to what's going on in UC Davis research, in Sacramento, California more broadly on this topic. And it also helps with the students networking and connecting them to this larger zero net energy research and efforts beyond the class. And that's how we do the class in a nutshell. Next slide, please. Yeah, so there's more information at the course website if you want to learn more about the course, particularly the past projects, or you can contact me directly. Yeah, thanks for listening. I'll hand it over to Melody now.
Thank you. So my name again is Melody Baglione, and I'm a professor in mechanical engineering. I teach controls courses, energy efficiency courses, vibration, other courses. But I have research going on in sustainable and healthy buildings, and I'm here to talk a little bit about how we use project-based learning in our curriculum, and most importantly, using project-based learning to address critical challenges facing us, such as sustainable buildings and healthy buildings. So some background about Cooper Union, in case you're unfamiliar with Cooper Union. We're a private school located in the East Village of Manhattan. We're founded in 1859 by Peter Cooper, who was an inventor, a philanthropist. He added a round elevator shaft to our historic foundation building. You can see here with the clock in the brownstone building. We are also in a LEED Platinum certified building that we moved into in 2009. We have a very 8-to-1 student to faculty ratio, about 1,000 students in art, architecture, and engineering. For 155 years, we were tuition free. That changed in 2014, but we are on a path, 10-year path to return to free. And currently, students receive on average 78% of their tuition covered. So again, we moved into this in 2009, we moved into a new academic building. It's 9 stories, 175,000 square feet, a laboratory building. It has a double facade, 2 500-ton chillers, water and air side economizers, radiant floor, day lighting and controls, green roof terrace, rainwater harvesting, VAV fume hoods, occupancy sensors, and a building management system. And last time, to tie back in last year's conference or workshop, we tried to identify needs and opportunities. So as faculty and as students, we can help our students learn the theory in the classroom by seeing real world applications. And facilities could benefit from applying fundamentals in a systematic approach to achieve and maintain efficient operations. So if we combine these two needs, there's an opportunity to engage students in campus projects with faculty, staff, and industry professionals. So currently we do this through different student opportunities. Every mechanical engineering student takes a process control lab course, and we've incorporated through National Science Foundation funding, we've incorporated building tours, we've incorporated learning materials into the curriculum where they learned about sustainable building features and energy saving measures and controls. Then students are all exposed to this Some of them become really excited about it and go on to get internships, both on campus and off campus. They do projects related to buildings as their senior capstone year-long projects, or they'll go on to do master's research. We've also, with funding from New York State Energy Research and Development Authority, NYSERDA, we've introduced a new elective energy efficient building systems course, which was co-taught by myself and an engineering energy consultant professional. So having industry and faculty in the classroom working together in identifying energy saving measures in our own building using actual data and site visits. As you can see, students out in the field taking data and measurements with flow meters, and then coming back and doing calculations and making recommendations to facilities as part of their projects on how to improve our efficiency. So some past student projects, and many of these you can find on my website. Baselining building energy consumption, tracing energy use using a Sankey diagram, contributing to our 40 by 30, so a 40% reduction in our carbon emissions by 2030 roadmap, and tracking progress towards our 40 by 30 target, creating a data historian using OSI Pi and energy dashboards and reporting tools, developing models of different energy saving measures, making recommendations to implement these energy saving measures, evaluating the savings. Some of those that we've done are condenser water reset, static pressure reset, temperature and airflow setbacks, and developing site-specific facilities training curriculum, which is also supported by NYSERDA. Some of the benefits over the years since is a reduction in our carbon footprint, which is great, but we still have a way to go to meet our 2030 goal of 40% reduction. But as Kurt alluded to earlier, there's much more benefits beyond carbon reduction and energy savings in our utility bills. We've also saved a lot of money, and we're also going to reduce New York State has implemented some of the most aggressive climate legislation in the country, and starting in 2024, buildings will get penalized if they don't meet their carbon reduction targets that are set by square foot. And if we continue on this trajectory, we won't have to pay these fines. So in addition, there's benefits to faculty and students and having projects with research and publications and going to conferences. And the website I haven't checked in a while on Google Analytics, but had a lot of hits in terms of and people reaching out with other energy projects. So it's a lot of visibility and a lot of networking and exposure for the students that helps them also get jobs in this industry. So tying this back to what we did last year, we thought we'd revisit. We did an interactive session through the chat where we asked participants last year to identify, to share some of the needs that they've identified and what are potential opportunities for addressing those needs. So these are actual responses from participants last year. Given this, I figured I'd use a little bit of the time to talk about what I think some of us have been working on over the past year. These are some of the things that we've done at Cooper over this past year, but specifically, I want to spend a little bit of time on how we've used project-based learning to help determine optimal air changes, especially with COVID and how many CFM per person or CFM air changes per hour. So we did this in two ways over the past year. We had a group of students work on their senior capstone project, and also in the energy efficient building systems course, we had projects addressing this. So first and foremost, we reviewed the resources that were available online from ASHRAE, and we began to try to develop site-specific HVAC recommendations. Projects also included developing computational fluid dynamics models of classrooms, including aerosol particles and CO2 concentrations, and experimental case studies of classrooms and machine shop of air quality measurements. So the students that worked on developing the CFD model and taking measurements, they first did so by surveying and measuring through as-builts, and also taking measurements of the classroom and the layouts of the rooms. Then they used CFD modeling. They developed a steady state HVAC model that modeled the airflow at different ventilation rates at different CFMs, and developed submodels to be able to model the diffusers. And once they, then they did research to understand how they could model breathing. So they did research on simplifying masked breathing. At first they started with just 3 humans or individuals in the classroom, a professor standing at the beginning of, at the front of the classroom. You can see the room has 3 inlet diffusers and 1 outlet duct, and 3 participants standing in the room. We combined these 2 models to sort of represent what, here's a simulation in CFD. So we modeled breathing for 5 minutes and then essentially turned the breathing off to see how long it would take the ventilation system to evacuate the particles. Obviously, there's a number of different ways we could set up these simulations. Here is results for 275 CFM. And in all the models, we saw that after about 10 minutes, there was sort of a well-mixed room, but there were also areas that had higher concentration. So the aggregate particle count was much higher for the lower ventilation rates, which makes sense. But we also found that where the people were relative to the inlet diffusers and the exhaust also contributed to the amount of particles from that particular individual lingering in the room. So person C's particles tended to linger in the room longer. Person C was further away from the inlet and exhaust inlet diffusers and exhaust. We also had a different group of students work on CO2 models. They looked at different localized CO2 concentrations under different ventilation rates and under different occupancies. So in this particular room, they modeled between 0 and 15 occupants and the localized CO2 concentration, and also at different elevations. So it also helped us to figure out where, when we eventually did our experiments, where should we put the CO2 monitors in the room. And students did air quality studies. We looked at the machine shop and also a classroom, and we did CO2 measurements as well as PM measurements. And we did a 4 hours worth of data at 400 CFM, or 3 air changes and 2 air changes of outside air. And then we added HEPA filters to room HEPA filters from Honeywell. And then we increased the ventilation and added the HEPA filters. We also did the increased ventilation without the HEPA filters, which didn't show. So you can see these results here. If you're adding HEPA filters and ventilation, it didn't seem to be any noticeable benefit. So it was analyzing the cost of one or the other, and it ultimately proved that it would be more cost effective to add HEPA filters. So a summary of the mitigating strategies that we recommended were to increase ventilation rates and to monitor CO2 concentrations, that in-room HEPA filters have an impact on particulate matter in the room, and also that HVAC features and the room arrangements and the occupant location within the room influences particle and CO2 concentrations and can produce areas of higher concentration. And then also the importance of maintaining humidity control. We looked at different humidity levels as well, and there's literature on that from ASHRAE. So the most important thing is that we used project-based learning and pivoted the projects that the students were working on given the pandemic, and really helped facilities to address important questions, but also got the students really important skills that also got them jobs. So now that Kurt and I talked about how we incorporate project-based learning in our curriculum, we want to give you a chance to sort of brainstorm with us on ideas that you have or things that you may have implemented. And we're going to use a Jamboard. So just to recap again from last year, these are the needs and opportunities. This year, we'd like to focus it on, once you've identified those needs and project-based learning opportunities, what are the challenges, and sharing some successes that you may have had. So Ali, are you going to pull up the Jamboard, or?
Ali? Oh, yeah.
Yeah, I am here. Alona, do you have that?
Yeah, let them know how to use it.
Yeah, I have it.
Oh, there's Helena has it. Stop sharing because I don't have the Jamboard. It's hard for me to drive with the changing slides and also looking at the chat, so I haven't had a chance to do that in the questions.
Can everybody see that?
Yeah.
Right, so I dropped the link into the chat, and what you're going to do is go to this left panel right here and just click on some Post-it notes and put your Post-it notes here.
And you know, and really you could put anything here, but we're pretty interested in something that, you know, it's, as far as energy education, project-based learning, you know, what have you a challenge in either implementing or just the challenges you actually have in the, you know, on your campus, and like some successes, either project successes or education success. Maybe you had your chair gave out some funding for it, or who knows what, but or you were able to get a student group to help you, whatever it happens to be. I could put one up for Meena here. She graduated. She I think got an A in that class. That would be a success. So anything, go for it. Wow, that's a good one. So I think Melody and I will just we'll read them off and we'll chat. They're addressing lack of interest from faculty, from facility staff.
Yeah.
Josh, are you on this call? So
I am, yeah.
Yeah, man, you got anything to say about that?
Yeah, facility staff are a pain in the neck. I think the key is that you got to get some kind of champion that can help make that connection on the operational side. I think that's really key. I mean, you know, I think it works both ways. It can be hard for facilities staff to find anybody on the academic side that wants to, you know, change up their curriculum and work with them on projects. So I think you got to have, like in our case, Kurt, we kind of, you know, we're both starting out and looking for those opportunities. And so sometimes it's you know, when somebody new joins, there's an opportunity to start something new. You know, maybe that works on both ends.
And also we've had like, for example, we wanted to work more with the medical campus that UC Davis had. So we just started with a small project, you know, not too much at stake, get a student on it, and we had a success. And I think that helped build the trust. So sometimes starting small, you know, build it and they will come. That seems to work.
Yeah, I would say definitely you do a project that doesn't take a lot of time from them, but you can show them that there's some value. And then I think for those that don't have a lot of support from their administration, come tomorrow, a little plug for tomorrow's session at 11:15, I think, where our vice chancellor is going to talk about how we were able to build an energy team in facilities that could do this kind of work. And really it came down to having support from our administration. And so if you don't have that, you can listen tomorrow and kind of hear her pitch for why it makes sense for a campus.
Yeah, so I think it's good to have a champion both on the academic side and on the operational side. Also, I think it doesn't hurt, you know, if the person on the academic side does have some kind of area of expertise that's falling into the facilities, you know, so they can just talk about some of the problems with some knowledge and background. Here's another one. I can't quite read it. Yeah, so making it, yeah, that's really important. And it's the same for believe it or not, it's also the same for on the academic, that the teaching side is, it can't be really more work at the end of the day for everybody, right? I mean, especially in relationship to how much gets done. So I think making sure, and
You froze, I think, Kurt.
I think we're waiting for Kurt to get reconnected here. So in the meantime,
I know. I'll send him a quick text.
yeah. So I mentioned, somebody brought up finding projects that can be completed in a single quarter or semester, and I would say for that, two important factors is sort of maintaining a really good knowledge repository to onboard new students in a new semester to continue working, because many of these projects are sort of not just can't be completed in one semester. Also at Cooper, at least, having a structure in place where sort of more senior students, maybe master students or students that have participated in the class before, you know, in some other capacity, as there's an intern or a TA, can sort of work with those students and to keep that project sort of alive and moving forward.
Yeah, and something that we do, because this has been an ongoing effort for like maybe 6 or 7 years now, is that we have projects that are continuing from one year to the next. So we're able to do bite-sized pieces of it. Also, when Meena started this, she was given a folder of all of the sort of protocol, all the projects, all of the different speakers. And so that does help. The more you do this, the more you get. Finding good clients with projects that are eager to help. I mean, it starts out kind of small, I have to say, in our history. And then I think the more you do it, if you get a decent reputation, just like any consulting company that can help. Yeah, there's lots of stuff now. Resulting product that makes.
Kurt, on that one too, I think we've found that if you offer somebody this type of help, I mean, it's free. They're going to get something out of it. We've found people are very eager to jump in and get some help. But usually the challenge is just getting something clearly defined from them in terms of scope, and then being able to give them a good deliverable. Yeah,
and I think identifying groups, like we're lucky we have this energy graduate group, but you know, where are your pool of students going to come from? And then, because I tell the clients, you're going to get 3 or 4 students for 10 weeks to do whatever you want, right? So often this is something that's on somebody's desk that they just need to address and they haven't had a chance. So, hey, remember that project you're supposed to do a feasibility study on? Our students will do that. And then I think coming up with projects that you can do in a quarter, yeah, that is a big challenge. I think one of the things that Meena mentioned earlier, one of the first questions we asked clients is, do you have data? So you want to go into it with data. You don't want to try to generate the data, because anything can happen, right, during that 10 week. For us, it's only 10 weeks. Let's see here. Any other? I didn't freeze again, I don't think. This is great. Oh, quality of work is adequate. I think that's a good one. I think that we suffered from that in the beginning, where sometimes there would be a report generated that we didn't even want to publish or send to the client. That does happen. We have, in the structure of the class that we didn't outline at this time, is that we have waypoints along the way to make sure the quality is good. Students give a project framing presentation in the beginning, which shows that they understand the problem very clearly. And there's a set of panelists that will interview them about, these are generally faculty and people from facilities, that will quiz them about their project. And then before they write their final report, we do the same thing. So we actually do a fair amount of quality control along the way in the project itself, but also as far as getting the right students and making sure the projects are well defined. Melody, anything on that?
Yeah, just adding, you know, making sure, like sometimes our students will write a very lengthy report on all the analysis they did, but that is just way too much for the facilities team to digest or have time to read even. So, you know, being able to come with a short executive summary or a short presentation that gets the point across and the recommendation across, and it's supported by evidence and data so that they can really get on board with it. And oftentimes when we come with, you know, a measure that we want to implement, we say, you know, it's a pilot, let's just try it, and we'll watch it all day today. We'll make sure that the controls, you know, when we go home, we'll revert it back to operator override, but let's try it. And then showing, okay, we did it, and let's look at we saved, you know, 30 kilowatts by running with, you know, condenser water reset, for example. But being able to get, you know, for example, condense a master's thesis into sort of a 2-page executive summary with, here are the key takeaways. And similarly, these little course projects, you know, the students put a lot of effort into maybe data analysis, but how do you have them visualize the data in a way that is convincing to the staff so that they're on board?
Yeah, and I just saw one that said students promote the course to potential other students. So I mean, hopefully Meena did that if she had a good experience. We do find that, you know, the new cohort asks the old cohort, you know, what courses should I take? I think if you have a terrible class, you're going to have trouble getting people in there. We now don't have trouble, but we want to have, like Meena said, we want to, you know, get people from design. We want to get people from economics. And that's part of the reason that we also recruit broadly, but we do. And we actually had Meena go out or we will have, Meena, and we had the previous graduate students talk to other classes to promote the class. So for sure, if you don't have a good product, you're not going to get the good students to work on it, and you're not going to get the good clients. So just like any consulting company, you have to really focus on your product, I think.
I want to go back to the Post-it note about, finding projects that can be completed in a semester. I mean, so that goes, Kurt, your model is this 1 semester long course that's interdisciplinary, which is great. And we certainly have a course that's 1 semester long as well, that the projects have to be designed so that they can be completed in a semester. And we usually have those be optimization projects. But in terms of just understanding buildings, and Cooper recently implemented what's called, and it's a structure that is actually at a lot of institutions. It started at Georgia Tech. It's called vertically integrated projects. We have a number of these projects where students just get 1 credit, but they work with faculty on small projects. I don't want to say small projects, but they work with faculty in research. But when they first on board, they're onboarding, and then they take this 1 credit project over a number of semesters so that they can work on these longer term projects. And there's this sort of vertical integration where upperclassmen and graduate students are onboarding younger students, and that helps sort of maintain the research, but also keeps sort of the projects alive beyond a semester-long course.
Yeah, and thanks, Melody, for that. I think we do it a little differently, but some of our students are actually working directly for facilities, so they'll know the projects that are really great. They'll take the class and they might champion that project. And then they might find themselves either getting paid or doing it as their master's thesis later on. We also hire undergraduate student assistants to work along on different kinds of projects. So we bring students, and sometimes they even work on a capstone, which might be a 3-quarter long senior project. Since we have faculty who are interested and involved, we can kind of try to get students in, like Melody was saying, like any way, shape, or form. But we do have a graduate student, Meena, for example, who tracks these projects all the way through. So we also think an important thing for a client is we're not just going to give you the report at the end of the quarter and we're done with you. We're going to ask you, what do you want to do next, right? And how can we help you? And then before the project, we're going to spend time with you to make sure we have the data. So it's I think, it takes a lot of time, but so far, so good. What else we have up here? Anything new?
Kurt, you also have a few questions in the Q&A box if you wanted to look
okay.
in there as well.
Yeah, so I'll add, this one's for you, Kurt. For the interdisciplinary UC Davis course, how do you overcome interdepartmental hurdles? For example, give students credit toward their degree in
Well, that's a great question. So I do have students coming to me saying, hey, I really want to take this, but I can't figure out a way to get credit for it, right? And so that happens. So, what we've done, we've done is work with other departments to try to get this as a, either elective or some kind of credit for technical. So we've done our best to do that. And the other thing that I have to say is sometimes I just tell the student, look, you should take this course. You may not get, you may be here longer or have to take more courses, but it's going to be worth it. And they often do, because they know that they want to get involved. So the answer I want to give you is, the students can always get credit and it's always streamlined, but it's not always like that. In fact, when we started this class, it wasn't even recognized it wasn't even in a department, and it wasn't supported by there wasn't an energy graduate group. We just knew that students were interested in it and they would come. So, 2 pieces of it. Some of the best work for students happens on stuff that's not necessarily part of their curriculum. So just remember that. And then the other one is any way, shape, or form you can do it. And so we've managed for graduate students to get as technical elective. I think that in mechanical, they can get electives. So those are 2 answers, I guess. I haven't read the second one yet.
It's essentially what cultural changes are needed to encourage exchange and engagement, since facilities management is not always interested in input or perspectives sort of from faculty, students, or people in energy sustainability roles.
Any insight on that, Josh? It's a hard one.
I think, I don't know, my perspective, and I guess it come from the faculty, is I think the challenges are both at the administration level, right? And but also building trust.
Yeah, and I would say, kind of like in any situation, client, I think that often, academics have made the mistake of thinking that they really know what they're doing just because they understand it on a high level. when really,
Mhm.
oftentimes it's the people who are down who really understand the details, and they need some help, but they don't need that much help, right? And so I think that's, to be a little bit humble is super helpful, and say, hey, and to not act like you have the answers. I think going into it like that is helpful. Also, if you have faculty who have experience, real on the ground experience with some of this stuff, then I think it also helps build trust. We're almost out of time. We got one more. Oh, that's a great one. Getting decision makers to look at the life cycle costs and metric. I see that as a success. We had a big success where our class helped Josh and his team
It's supposed to be.
get like $160 million to put steamed hot water on our campus. And that was really just making a good economic case for it, technical and economic, and really backing it up. And using these life cycle and especially costs. Josh, you have anything to say about that?
Well, I think it definitely holds weight when a group of students can put together a really compelling case like that. It's not like that was the one thing that decided it, but it did get our administration's attention and help make the case in a way that we would have had to pay probably a couple $100,000 to a consultant to do a similar type project. And we're doing the project now, so it actually turns into real things on the campus, which is great for the students. It's great for us. I think the one takeaway is that there's just a lot of synergy with this type of work, and we should stop making excuses and find ways to make it happen on campus.
Yeah. And Josh, I'd say the one thing about how do you get projects and people interested. Often the way I say it is, what's sitting on your desk? What project is sitting on your desk that you just need to do and you don't have time to do it? I could give a set of really smart students work on it for 10 weeks. What project that you just don't have time to work on right now, and we'll do it for you. So that's one approach. I think we're just about out of time.
In fact, Kurt, if people do have those projects and they don't have the students, they can probably reach out to you. We might be able to incorporate it into our class.
That's true. We sometimes we usually have one or two projects that are not on UC Davis campus. So anyway, Jamboard, I've never used it before. It seemed like it worked pretty well. I really appreciate you guys' input. Please reach out to myself, Melody, or Meena, Josh, anybody, if you either have great ideas for courses, and if you want to come to, to Davis for a couple of days and see what we're doing, or go out to Cooper Union. So yeah, thanks a lot. And I look forward to seeing you tomorrow.